Hello everyone, welcome back to the third video of Relations and Functions chapter. In this video, we are going to learn about the concept of functions. Now, let us understand what this term of functions mean. Functions is also a certain type of relation, but we can say it is a special type of relation. So let us understand the definition of functions, then I will explain to you by giving an example. So what is the definition of a function given? A relation f, I say, from A to B, okay? A relation f from A to B is said to be a function. What is a condition? If every element, very important, if every element of set A has a unique, very important word, as a unique image in B. So who is this image? Now suppose I have two set A and B. The answer, now suppose, let me give you one example. Yes, so once again, let me read the definition. A relation f from A to B is said to be a function if every element in the set A, not even leaving a single element in the set A, every element should have unique image. What is the meaning of unique image? One and only one image. So here unique could be written as one and only one. Okay, so one and only one image should be there. Now for example, let me give you one example. Suppose A is equal to 1, 2 and 3 and set B is equal to 4, 5 and 6. Okay, 4, 5 and 6. So A and B is given to me and the relation is defined as R is equal to set of all x comma y such that y is equal to x plus a 3. Okay, where x belongs to set A and y here belongs to the set B. Now write the answer of this relation, then we will check whether this relation becomes a function. If it has to become a function, then unique image, unique element image should have. Okay, so let us check whether that is possible. So what is my answer here? X belongs to the set A, so x is equal to 1. When you take x is equal to 1, what you get? Y is equal to 1 plus 3, which is equal to 4. So what is R from this? You are getting, when x is 1, 1 plus 3, you are getting 4. When you take x is equal to 2, 2 plus 3, how much? You are getting 5. When x is equal to 3, you are getting 3 plus 3, which is equal to 6. So 3 comma 6 is the answer. Okay, now how to check whether this is a function or no? Let me make you understand by the arrow diagram. Okay, so here you have two different set, let us take. Okay, set A and set B. So set A is having 3 elements, 1, 2 and 3. Here set B is having 4, 5 and 6. So what is this telling us? From 1, who is the image? This 4 is called the image of 1. Okay, that 4 is called the image of 1. So from 1, your arrow mark goes to 4. Next, from 2, the image of 2 is 5. Image of 2 is 5. From 3, image is 6. So image is 6. So now check the definition. A relation, so this is a relation and that is said to be a function when, if every element, first to check if every element of A is occupied. Yes, everything is occupied, there is no element left out. And all the elements should have only one image. Check whether it is having only one image. Yes, so that means the condition of function is satisfied. Therefore, we can say this R is a function. This R is a function. Hope the idea is clear. Let me give you one more example. Now, suppose we have a set A where it's having 10 students. Okay, so 1, 2, 3, or let us take 5 students. And the set B, which is having all the months of a year, starts from January, February to December. Now, Take the first student. Okay, so first student, register number 1. Think this student is born in January. Okay, now there is another student. Now, can this happen? Tell me, can this student also be born in January? Okay, so like that, all are born in one month or the other. Now, what is the condition? Check the definition. I'm asking you whether this can be a function or no. What is the image of 1 January? What is the image of 2 January? It is possible, no? 2 students can be born in the same month. Possible, right? So here, how to write 1 comma January, 2 comma January, 3 comma February, 4 comma, now suppose 4 comma December, and 5 comma March. Okay. Now, what is the definition telling us? Every element of the first set, that is 1 to 5, should have unique image. Yes, they are having unique images, only one image. Understood? That is, image of 1 is January, image of 2 is also January. Okay, so what should come to our mind here is this number, that is this type. For example, here, when it cannot be a function, let me tell you. Now, same 1, 2, 3, 4, 5 is there, and we have January, February, up to December is there. Okay, so now is it possible a student born in January also, born in February also? Is that possible? Not possible, no. One student is born in only any one of the month. Can a student be born in January and February also? So suppose you write this, how we are going to write 1 comma January, you are writing 1 comma February. So, and it goes on. So whether to check it is a function or no, and if ordered pairs are given, one trick I can give you, just to check the first numbers. If the first number is not repeated, then we say yes, it is a function. Don't bother about who the second number in the ordered pair is. That we are not bothered. But bother about the first element. First element should have unique image. Okay. But here you see 1 is repeated 2 times. That means this particular relation cannot be a function. Whereas this particular relation, you check here, the numbers are not repeated. So this can be a function. Hope the idea of function is clear now. So what is the definition of function once again? A relation is said to be a function if every element of the set A, that is first set, should have unique image in the set B. That means that first element cannot be having two images. Is that clear to you? Yes, each element should have only one image. We are not bothered if 2 of them are having the same image. Okay, try to understand this concept. Clear? Yes. So now we will learn few types of functions. Okay, so let us learn few types of functions. Yes. So these are 5-mark questions which will appear in the board exam, annual exam. Okay. Types of functions. First question, let us take define identity function. So the definition, then we have to draw its graph, then write the domain and the range. I said it's 5 marks. 1 mark for the definition, 2 marks for the graph, and 1 each for domain and range. So let us write the answer first. Let us write the definition of identity function. Okay. So what is an identity function? A function, okay. So a function f from R to R, that means they are real valued function. Okay, R to R, that is real value. Domain is also R, codomain is also R. So function f from R to R defined by f of x is equal to x. For every x belongs to R is called, okay, for every x belongs to R is called an identity function, is called an identity function. Now, what is the meaning here? Identity is like looking at the mirror. If I am looking at the mirror, I can see my own image. If 1 is looking at the mirror, it is getting 1 only as the image. 2 is looking at the mirror, then the answer is 2 only. So same way, how you can define that? It is defined by f of x is equal to x. So whoever that x is, same x will be there as the image. Okay. Yes. Okay. So a function f from R to R defined by f of x is equal to x for every x belongs to R. That means not even a single number should be there without getting that image. Okay. So for every x belongs to R, that is called a identity function. Now let us try to draw the graph of identity function. Okay. So just graph means we have the x-axis and the y-axis. Okay. So x-axis and the y-axis. Now we have the definition f of x is equal to x. So let me plot few points here. 0, 1, 2. Here we have -1, -2. Here you have 1, 2, and here -1, -2. So what will happen if I take x is 0? So f of 0 is equal to 0. F of 1 equal to 1. Use the definition. F of -1 is equal to -1. F of -2 is equal to -2. So plot these points. So when x is 0, y is, that is f of x is nothing but y, no? So that is also 0. So here we have the first one. Next, if x is 1, y is also 1. So we have this point. When x is 2, what will I get? I'm getting here f of x also 2. X is -1, my answer is -1. X is -2, I'm getting y also -2. So therefore, what is the graph you are getting? You are getting a straight line graph which passes through the origin. Okay, just join these points. So you are getting a straight line graph. So this graph, whichever we have drawn, is f of x is equal to x. That is the graph of identity function. Hope this idea is also clear how to draw the graph. Next, what we are left out with, write the domain and the range. So domain in these types of function is always the real valued function. So domain is equal to R. What about the range? Range, here you find whatever number you give, same number is coming out. That means if you're giving all real numbers, what should be your range? All real numbers only. Yes. So domain is also R here and range is also R. Hope you have understood the first type of function. Yes. Okay. Next, we shall move on to the second type of function, which is the constant function. Okay. So define constant function, draw its graph and the domain and the range. So first, let us write the definition of a constant function. Okay. So definition: a function f from R to R. So a function f from R to R defined by f of x is equal to some c. C is a constant, okay, where c is a constant, comma, for every x belongs to R. That means all the values of the domain x is equal to x belongs to R. Answer what you are getting, constant c. Okay, is called a constant function. Is called a constant function. Now, let us see how to draw its graph. Okay, so now here let us draw the x-axis and the y-axis. So here 0, 1, 2, -1, -2. Here you have -1, -2, 1 and a 2. Now suppose I take that f of x, that c value is equal to 2. Okay, c value is equal to 2. Now, so what will happen? Any value you give for x, your answer should be 2 only. That means if you are taking x as 0, my answer is 2. If you take x as 1, my answer is 2. If you take x as 2, then also answer is 2. X is -1, answer is 2. X is -2, still answer is 2. So how we are going to get? You are getting a horizontal line parallel to the x-axis which passes through that constant 2. Okay. So this is the graph which you got, and this graph is f of x is equal to 2 which you have taken. Okay, which you have taken. So this is the graph of a constant function. Clear? Now, what about the domain? So domain is for all x belongs to R. So domain is R. What about its range? So whatever real number you take, where it goes and reaches, who is the image? It is constant C. So it is equal to C. Here I have taken let C is equal to 2 and given this example for you. Hope this idea is clear. Yes. We move on to the next type of definition, the function modulus function. Okay, very important. Modulus function. So define modulus function, draw its graph and then domain and the range. Okay, so let's see what is this modulus function. A function f from R to R defined by f of x is equal to mod x. This is modulus of x for every x belongs to R, where mod x, what is the definition? This is equal to x if x is greater than or equal to 0. It is equal to minus x if x is less than 0. Okay, is called a modulus function. Is called a modulus function. So next step, we want to draw the graph. So how do we draw a modulus function graph? So we have the x and y axis. So here it is x axis and y axis here. So we have 0, 1, 2, minus 1, minus 2, here 1, here this is 2. Okay, so let me take few points to draw the line, no? To draw the graph, we want few points to plot on it, okay? Yes, so suppose I say modulus of 0. What is modulus of 0? The term, see, what is the definition telling us? Modulus of x becomes x, when x is equal to 0. So whatever is inside the modulus sign, that is my answer, so therefore it is equal to 0. What is modulus of 1? Equal to 1. Modulus of 2? Equal to 2. What is modulus of minus 1? What is the definition telling us for all the numbers less than 0? What is it telling us? So the definition is telling us put one minus sign. Yes, I put one minus sign, and whatever is inside the modulus sign bring out. So minus of minus 1, so that is equal to plus 1. That is how I'm getting plus 1. Okay, sometimes we remember looking at the modulus, oh, that is someone who is galloping, who is taking in all the negative signs. No, it is using the definition. Okay, yes, what is modulus of minus 2 then? What is the definition telling for all the numbers less than 0? Put one minus sign and then put who is inside the modulus sign. So therefore you're getting 2. So let us plot these points. When the modulus of 0, your answer also is a 0. For 1, your answer is a 1. For 2, modulus of 2 is equal to 2. Modulus of minus 1, it is 1. Modulus of minus 2, you are getting that answer equal to minus 2 only. So what is that you're going to get? You have got a graph. Okay, so you have got a V-shaped graph which passes through the origin. So this graph is nothing but f of x is equal to modulus of x. Okay, hope it is clear. Okay, so you are getting a V-shaped graph which passes through the origin. There is no chance of getting the negative values. The lower the x-axis, no chance of getting it. So what is the domain of us now? What is the domain of this modulus function? Domain is R. What is the range? So whenever you take the negative number also, what you got the positive. So 0 is possible and all the numbers more than 0. So infinity. So closed interval 0, comma, open infinity. Open because infinity is always open. Or you can write range as non-negative. It cannot become negative. Non-negative real numbers. Okay. So I hope this definition and the graph domain range is clear to us. Yes. Next we move to the fourth type, that is the Signum function. So define Signum function, draw the graph and the domain and the range. Let us see now what is this Signum function. Okay. Yes. So what is the definition? So the definition tells us a function f from R to R defined by f of x is equal to Signum function, no? F of x is equal to 1 for all the numbers greater than 0. Okay, so for all the numbers greater than 0. It is equal to 0 when you are having x is equal to 0, and it is equal to -1 for all the numbers less than 0. For every x belongs to R is called Signum function. Is called Signum function. So now, whatever real numbers you take from in the domain, your answer will lie only 3. Either it is a 0, or it is a 1, or it is -1. So let us see how to draw the graph now. So I have x-axis and y-axis again. So here x and y-axis. So this is 0, 1, 2, -1, -2, 1, 2, -1, -2. Okay, so what is the graph telling us? When x is equal to 0, that my answer is 0. So this is my answer. Okay, so when x is equal to 0, f of x also will become 0. Next, I take one more. When x is equal to 1, that means it is coming under greater than 0. So what is f of x is equal to? 1. When x is equal to 2, what is it f of x equal to? It is also 1 because it is greater than 0. All the answer is equal to 1. Next, suppose I take negative. X is -1, then f of x is equal to -1. When x is equal to -2, again it is a number less than 0. F of x is also equal to -2. So let us plot this graph. For x is 0 is over. Now, all the values, see, right side of 0 is all positive numbers. For all positive numbers, what is my answer? 1. Okay, so here I have an open 0 and all the numbers goes this side. So what is this? Nothing but this is f of x is equal to 1. Okay, because here I'm having at 0, answer is 0. That's why it's a written up open 0 here. Okay, and for all the numbers less than 0, negative answer, what should be our answer? -1. So here also we have the open 0 and here the line moves towards the left side. So this is f of x is equal to -1 and this point is f of x is equal to a 0. Hope the graph is clear. Okay, now tell me, what is the domain? What is the domain? Domain is real numbers. What about the range? So range is whatever real values you take. These are the only 3 numbers which I am getting, either 1 or -1 or a 0. So range is -1, 0 and 1. So this is the answer. I hope the idea is clear. Yes. Now we have one more. Let us learn one more, and that is nothing but the greatest integer function. So define greatest integer function, draw the graph and write down its domain and range. Okay, so let me go to the answer definition. A function f from R to R defined by f of x is equal to the square bracket of x, that is denoted nothing but the greatest integer of x. So f of x is equal to square bracket of x for every x belongs to R is called greatest integer function. Is called greatest integer function. Let us understand what is this square bracket. Where this f of x, where f of x is equal to, this is the square bracket of x, and that answer is equal to -1. I'm giving you the example. -1 for x is greater than or equal to -1, less than a 0. A 0 for x is greater than or equal to 0, less than 1. 1 for x greater than or equal to 1, less than 2. Let me make you understand how did I get this. Now, greatest integer, don't get confused with the approximation. So what is the greatest integer telling us is, if your x is an integer, then the answer will also be an integer. So when, what is it? Greatest integer of x 0, answer is also 0 because it is an integer. Okay, so here it's, look at the second one. When it is equal to 0, answer is 0. But here, okay, when I have 0.5, 0.5 is not an integer. So what is greatest integer of 0.5? In that case, you have to see the leftmost integer of that. What is the leftmost integer? 0. Okay, so here all the values less than 1 will have the same answer, 0. Let me go to another point, 1.9 let me take. Okay, so this is 2, 1.9 is somewhere here. Don't mistake and write this as 2, that is approximation. So what is the greatest integer of 1.9? It is not an integer. So who is the leftmost value? That is equal to 1. So that is, I have written for x greater than or equal to 1, less than 2, my answer is equal to 1. So now how to draw the graph? Let us see how beautiful this graph is. It is a step function. So how we have the steps, so like that this graph will become. Okay, so let us try and understand the graph. Okay, so we have the x-axis and the y-axis. So here we have 0, 1, 2, minus 1, minus 2. Here you have 1, 2. Here you have minus 1. You have minus 2. Okay, when x equal to 0, my answer was equal to 0. Okay, yes. But for all the values 0.1, 0.2, 0.3, then what is your answer? My answer is equal to 0 only. So, but when I have 1, I'm jumping to 1. So that means all these values will have except 1. Okay, so open 0 there. So all these values from 0 to close to 1, all the answer becomes 0. But when it is 1, it goes to the higher point. Okay, 1. And for all the values 1.1, 1.2 till 1.9, my answer is 1 only. Okay, but when it is 2, what will happen? It will jump up high there, and it goes on like this. Same way. Now come to the left side. Okay, come to the left side. For all these values, now suppose I have minus 0.5. Who is my answer for greatest integer function? It is minus 1. So I'm reaching here. That means for all the values here, you are getting the answer minus 1. For minus 1, it is minus 1. All these values in between minus 2 and minus 1, who is your answer? Minus 2. Okay, yes. So here, this is your answer, minus 2. So all these values. So how is the graph? How you can look at this as it is nothing but the step function. So this is f of x is equal to greatest integer function graph. Okay, so now tell me the domain and the range. So what is the domain here? Domain is nothing but the real numbers. And what is range here? Whatever you find for real numbers, answer will be integers only. So therefore range is a integer. Hope this idea is clear. Yes? Okay, these are the 5 functions which you have to learn. Now we will go to the exercise, the last exercise of this chapter, exercise 2.3. So what is the first question telling us? Which of the following relations are functions? Remember the function definition. If it has to become function, and what I have told you, whenever ordered pairs is there, the first number should not be repeated. Suppose it is repeated, then it is not a function. Okay, yes. So if it is a function, then you have to find its domain and range. Okay, so now let us check A answer. So look at this now, check whether the numbers are repeated. 2, 5, 8, 11, 14, 17. No, it is not repeated. So I can say, yes, it is a function. Okay, the first one, it is a function. Okay, if it is a function, I have to tell its domain and range. So who is the domain of the first one? Domain means all the first elements. So 2, 5, 8, 11, 14 and 17. What is the range? Range is nothing but the set of all second elements. So here what you find, range is only 1. What type of function is this? Constant function. Yes, very good. Okay, so coming to the second one, B. So we have 2, 1, 4, 2. So just check whether the second one is a function or no. Check whether the elements are repeated. 2, 4, 6, 8, 10, 12, 14. No. So it is a function. So second one also is a function. Okay, what is the domain then? So domain is nothing but the set of all first elements. So 2, 4, 6, 8, 10, 12 and 14. What is the range of this? So range is set of all second elements. 1, 2, 3, 4, 5, 6 and a 7. Next, look at the C question. C question, yes, check the ordered pairs. 1, 1. 1 is repeated. If the number is repeated, first number repeated, then it cannot be a function. So it is C question, it is not a function. And if it is not a function, I'm not bothered about domain and range. Hope this idea is clear. Yes. So next we move on to the next question, the second one. Here what they have asked us, find the domain and range of the following. Let us take one at a time. Okay. Yes, we'll take the first one. So first one is f of x is equal to minus and modulus of x. Now you have just now learned what is modulus of x. So modulus of x, we got a graph, a V-shaped graph which passes through the origin. That means all the values in the images, no, we got the positive answers only. Was there any chance of getting negative? No. Okay, so here this modulus of x is always giving me the positive answers. So whatever positive, now suppose 4 answer, you got 4. But if you multiply with the minus sign, what will happen? It will become a negative number. Okay, so whatever the number is, when it comes outside the modulus sign, it is the minus. Okay, yes, so let us write here for every, okay, understand this question. For every x in the real numbers, x belongs to R, what you have, modulus of x is always either 0 or greater than 0. Okay, now we have minus modulus of x. So that means minus of this modulus of x, what will happen if I multiply with minus? The inequality should change its sign. So this is less than or equal to 0. So who is this minus of modulus of x? Nothing but it is f of x. So you are having f of x is less than or equal to 0. Okay, so here you have the negative number less than or equal to a 0. So what is the domain now? So we have domain of this is a real numbers. F of x means the image. Okay, yes. So what is the range here? Range we are having all the negative numbers. Okay, so here we have 0 and we have minus infinity and we have plus infinity. Okay, so here all these numbers are included. So that means 0 is included. So minus infinity, always write the small number first and then 0. Since equal to sign is there, this is included, this infinity always open. Now let us go to the second one, B question. F of x is equal to root of 9 minus x square. Okay, now whenever root question is there, an idea should come to our mind. If I want real values, then root cannot become negative. So what is the firstmost condition there? The condition is under the root, it has to be always greater than or equal to 0. Okay, so this f of x will be defined. So f of x is defined only if 9 minus x square has to be greater than or equal to 0. So what does this imply? 9 is greater than or equal to x square if I add x square on both sides, and this is nothing but x square is less than or equal to 9, or I can say x is greater than or equal to minus 3 less than or equal to 3. So this becomes the domain of f of x, that is closed interval minus 3 to plus 3. Now remaining is how to find the range. Okay, now for any value, see, range will depend on the domain. Now say this f of x. So we have f of x is equal to root of 9 minus x square. Any value you take in between minus 3 and plus 3, what is that you're going to get? You are getting it as, suppose you take 3 or minus 3, what is the possibility to get a 0? You are getting a 0 or the positive number. Okay, or here you're getting a 0 to 3. Correct? Yes. So how do we write that? For any number which belongs to minus 3 to plus 3. Okay. So for any value of x, in closed interval minus 3, 3, that is the domain, f of x will lie between, either it can be 0 or it can be 3. Okay, between 0 and 3. So therefore, what is the, this becomes a range then. So let us write domain is, therefore domain is always x values. So domain is closed interval minus 3, 3 and range is closed interval 0, 3. Okay, so this is my answer for the second one. Now let's go on to the next question, question number 3. So what is the third question telling us? A function f of x is given by 2x minus 5. Okay, write down the values of f of 0. So let us take f of 0. So what comes to my mind over here? In place of x, I have to put a 0. So this is 2 into 0 minus 5. So therefore it is 0 minus 5, which is equal to minus 5. So that is your A answer. Next you have B question, f of 7. So where there is x, now put 7. So it is 2 into 7 minus 5. So it is 2 7s are 14 minus 5. So therefore we are getting that answer 9. Okay, so that is B answer. Coming to C question, f of minus 3. So that is equal to 2 into minus 3 minus 5. So therefore it is minus 6 minus 5. So and answer is minus 11. Hope you have understood this one. Clear? Yes. Next, we move on to the next question, question number 4. We move on to the next question, question number 4. So what is the fourth question telling us? Let f equal to, okay, so let f equal to minus 1, 1. Here we are having f is 1, 1, 2, 3, 0, minus 1, minus 1, minus 3. Be a linear function from z to z. Question tells me find f of x. Linear function, understand this. They have not given which function. So how do I define a linear function? We have learned this in our lower classes. How do I get this answer? Okay, yes. So here we are having a linear function. So therefore we are having, let us first write the linear function. Okay. Yes. So the answer here is f of x is equal to, let us write the linear function as ax plus b. Now I want to find the values of a and b such that I can find f of x. So for this, what we will take, let us take this first ordered pair. 1, 1. Now what is this 1, 1 telling us? 1, 1 is telling us, 1, 1 is telling us here you take x value as 1 and f of x is also 1. So 1's image is 1. Is that clear? So here in place of f of x, if I put 1 is equal to a into 1. So that is a plus b. Okay, so we are having here a plus b is equal to 1. Call it first equation. Now take this ordered pair 0, minus 1. Let's see what we are going to get. So 0, minus 1 we are going to get here. This is my x and this is my f of x. So here take x is 0, f of x is minus 1. So you're getting minus 1 equal to a into 0 is a 0 plus b. So you're getting b is equal to minus 1. Okay, so b is equal to minus 1. Next, substitute in equation 1. So substitute b is equal to minus 1 in equation 1. So what is that you're going to get? You're getting a minus 1 is equal to 1. So a is equal to 1 plus 1. So a is equal to 2. So I got the values of a and b, substitute in f of x. So therefore f of x is equal to a into 2 plus b here. F of x is a is 2, isn't it? So 2 into x plus a b value is minus 1. Okay, b value is minus 1. So therefore f of x is equal to 2x minus 1. This is the answer for the fourth one. Okay, let's move on to the last question. Yes, so last question of this chapter. Find the domain of the function. Domain means where does x value belong? And f of x is given as x square plus 2x plus 1 divided by x square minus 8x plus 12. Whenever I have a rational function, what should come to my mind? Whenever I have a rational number, what do I take care of? Such that the denominator won't become 0. So I'm bothered only about when this denominator will become a 0. So this is a quadratic equation here, okay? So how to solve this equation? I have to find all possible values which can belong and which cannot belong. Okay, so I have a quadratic equation x square minus 8x plus 12. So when I multiply, I should get 12. When I add, I should get minus 8. Which are the two numbers? Minus 6 and minus 2. When you multiply, 12. When you add, minus 8. Satisfied. So what is the shortcut? How to find the roots? X square, you write x and write these numbers minus 6 and minus 2. So x minus 6, x minus 2 are the factors. So what is the value now? When it will become 0? When x value is equal to 2 or a 6. So if this domain has to be defined, then all possible real numbers is allowed except which are giving this 0 in the denominator 2 and 6. So how do I write the domain then? So therefore domain is equal to all real numbers except, that means minus, of 2 and 6. These two values, if I write, the denominator becomes 0 and the function is not defined. So this is the domain of f of x. Hope you have understood the chapter thoroughly. Yes, thank you so much for watching.